Hello and welcome to our channel Mech Explained. I am Abhijit and today I will derive the Bernoulli's equation from Euler's equation. So let's start. So here we are taking a fluid element, okay, where the fluid is flowing from this direction and going out from this direction, okay. So before doing the derivation, we should know some key notes or key elements by remembering which, it will be more easier for us to do the derivation. So the key notes are force due to motion. So the fluid is flowing, so there will be a force due to the motion. Okay, force due to gravity and Newton's second law. Okay, what is Newton's second law? Force equals to mass into acceleration. So in this fluid element, because the fluid is flowing from this side, there will be a pressure force, okay, pressure force in the inlet direction. Force equals to pressure into area, right? So inlet force in this direction. We know this force will be in opposite direction. We always know force is always in opposite direction. So the force in the outlet will be P plus del P by del S into ds into dA. That means here pressure is changing with respect to length. In this fluid element, the length is ds, right? So pressure is changing with respect to length, okay. And there will be a force due to gravity. So this is the force, W equals to mass into gravitational force, right? So W equals to mg, and this weight is acting with theta direction with the fluid flow, and this weight is acting in theta direction with the fluid flow, okay. We know density equals to mass by volume. So mass will be density into volume, and volume equals to area into length, right? Here elemental area is dA, okay, dA, and length is ds, okay. The length of the fluid element is ds. So volume will be dA into ds, and mass will be rho into volume, okay. So we can put this value of volume here, right? So that will be rho dA ds. Mass will be rho dA ds, right? So we write mass equals to rho dA ds, and there is a g, so rho g dA ds, right? But here the component is angle in theta direction, right? So this component will be named as rho g dA ds. This is horizontal component, right, with respect to theta. So this will be rho g dA ds cos theta. Fine. Now we know the third step is Newton's second law. Newton's second law is equals to force equals to mass into acceleration. So force acting in x direction, okay. There is no y direction, right? There is no force in y direction. So force in acting in x direction, if we take this as positive, and that means this will be negative because it is in opposite direction with respect to this, and this force it is here, this will be also in opposite direction, so it will be negative. So this is P dA minus P plus del P del S into ds dA. This is also minus, and this is also minus rho g dA ds cos theta, okay, equals to, we know mass into acceleration, force equals to mass into acceleration. What is mass? Mass equals to rho, we can put the value of v equals to dA ds, that means rho into dA ds. Rho into dA ds equals to mass and acceleration, okay. P dA plus P dA minus del P del S ds dA, okay. So we are writing this P dA minus del P del S ds dA minus rho g dA ds cos theta equals to rho dA ds into acceleration, okay. So this PdA and this PdA will be cancelled out, and now we have to know the acceleration, okay. Acceleration is change in velocity with respect to time, okay. Change in velocity dv by dt. This is not del t. I have written this, but this is dv, okay. Dv by dt. This is dv by dt. So acceleration is change in velocity with respect to time. So here velocity is the component of s and t. That means velocity is changing with respect to distance and time. With respect to distance, velocity is function of s and t. So that means velocity is changing with respect to distance and time. So let's partial differentiate. Dv by dt equals to dv by ds into ds by dt. Here we are partial differentiate velocity with respect to s, and here we are differentiating with respect to t. That means dv by dt into dt by dt, right? So this will be cancelled out, and remaining things are dv by ds and ds by dt. ds by dt means ki ds is length and dt is time. That means change in length with respect to time. This is our velocity, right? Acceleration we know, change in velocity with respect to time, and velocity is change in distance with respect to time, right? So we can write ds by dt equals to velocity, right? ds by dt equals to velocity, and dv by ds remains as it is, plus dv by dt. dv by dt is change in velocity with respect to time, but here because this is steady flow, so the velocity change of velocity with respect to time is 0. Okay, because this is steady flow, Bernoulli's equation assumptions we know from, I have told it in the previous lecture, that Bernoulli's equation you have to take it as non-viscous flow or inviscid flow, steady flow, incompressible flow, irrotational flow. So this is steady flow. That means change of velocity with respect to time is 0. So dv by ds into v and dv by dt equals to 0. So that means acceleration comes down to v into dv by ds. Okay, this is our third equation. Now put this value of acceleration at here, right? We can put this at here, minus del p del s ds dA minus rho g dA ds cos theta equals to rho dA ds into v dv ds. Okay, we are putting just the value of acceleration. Look, this looks like very big formula or kind of something, but this is not at all but this is not uh, much difficult. You just have to know the key elements that I have told, and you just have to proceed. You only have to practice once or twice, then it will be very easy to you. So this ds and this ds is, this is ds, right? This is ds. Okay, so this is ds, this ds and this ds cut out, cancels out. So dividing this, now we are having this equation. Okay, so dividing this by rho dA ds, we will get rho dA ds. We are dividing all these equations. Okay, so we will get del rho by rho ds. Okay, minus g cos theta. Okay, rho dA ds is cancelled out. That means g cos theta. Here rho dA cancels out. That means v dv by del s, ds. Okay, v dv by ds. This is ds. Taking all these components in the right side, or calculating this, we will be getting all the values will be positive and equals to 0. So del p by rho ds plus g cos theta plus v dv by ds equals to 0. So now this is ds, right, in this direction, and this is the z, that means the amount of distance from the datum line. This is dz, right? This is dz and this is ds, and these both are taking an angle of theta. Here also it will be theta, right? Theta. So we can write dz ds. This is the horizontal component and this is the hypotenuse, right? And this is the vertical component. So cos theta equals to bhumi by otibhuj, that means dz by ds, right? We can put this value of cos theta at here. Okay, we'll be putting the value of cos theta at here, and this will be looking like del p by rho ds plus d g dz by dx plus v dv by ds equals to 0. Okay, now what will we do? You can see that here ds common, so we will be dividing these three values by this left hand side and right hand side by ds. Okay, so this will be dividing by ds, del p by rho plus g dz plus v dv equals to 0, and this is the Euler's equation. But we have to know the Bernoulli's equation, right? So by integrating Euler's equation, we will be getting the Bernoulli's equation. Okay, derivation of Euler's equation is also important. So this will be the Euler's equation, and now we'll be deriving the Bernoulli's equation. So now we are integrating the Euler's equation. Our integration of del P by rho plus G dz plus integration of V dV equals to 0, and we are also integrating this also, right? So this will be P plus rho plus Gz plus V square by 2. This is rho because rho is constant, okay? So we are not integrating rho, so the del P is changing to P, but rho is same, okay? And integration of 0 is constant. Now we will be dividing this equation with G. We are getting P plus rho G plus Z plus V square by 2G equals to constant. So this is the Bernoulli's equation, okay, where this is the pressure head, this is the kinetic head, and this is the potential head. We know this as energies, P by rho G plus V square by 2G as kinetic energy, and this as potential energy, but this is not energies, this is just potential head. And the potential, what is head? Energy per unit weight is head. We are writing this in per unit weight. That means potential energy per unit weight, kinetic energy per unit weight, pressure energy per unit weight. This is why I am writing pressure energy, pressure head, kinetic head, and potential head. Okay. Now let's look at the statement again. What does the Bernoulli say? In a steady, ideal, incompressible fluid, the total energy at any point of the fluid is always constant, right? And here we are integrating this because we are taking a fluid element, and for the whole element or the whole pipe or the whole section we have to integrate it. So this is all for this lecture. Hope you enjoyed the lecture and learned the concept very well. If you like the video, then please like, subscribe, and share the channel with your friends and to the people need this. Thank you.